Okay, so we are doing areas of data continued. Today we did intros. We're going to go over integration management, data quality, and references and metadata. So these are the aspects of data that we're going to cover today. So integration management. We touched on this slightly last week, but integration management is the idea that we take those siloed aspects of data that live within any organization. You know, people store their data in Excel spreadsheets. They store their data in these disparate applications, in these antiquated on-premise servers that are just sitting in basements somewhere, not connected to the internet, not connected to anything. They're just holding data. And so what integration management allows us to do is to mine that data, not necessarily in a true data mining sense, but bring that data into a centralized hub and actually use that data for productive quality processes, as opposed to it just sitting stagnant in its individual siloed application. So there are a number of ways to go about integration management. ETL is extract, transform, and load. So we're going to talk about ETL and ELT, which stand for the same thing. They're just in different different order. So when you extract, transform, and load, this is an integration method that migrates data into a data warehouse. But before loading the data from its application, so the source data set, into this data warehouse, there's some transformations happening. So maybe you're de-identifying some personally identifiable information, or maybe you're aggregating data up into a demographics aggregation as opposed to individual row level data for individuals. So this does two things. It allows for that level of security, if you want that level of security beyond the or before the data warehouse integration, because you can do those transformations within the system before the data hits that data warehouse. The other thing this does is it saves a lot of space and a lot of processing. The data itself takes up a lot of space, and if you do processing within a data warehouse, that can be expensive because you're doing transformations on fairly large data sets, whereas when you transform initially, your later abstractions or changes in perspective or additional transformations are much smaller and going against much smaller data sets. So it can save you some money. That is compared to ELT, which is extract, load, transform. So extract, load, transform means that you take all of the data in its raw form from the application and migrate it directly into your data warehouse. That means you have all of this raw data to play around with. You have this really big sandbox to build castles of data with. It can be expensive though. So you're storing all of this information that you may or may not use down the line. It also has the potential to open up security concerns because you are hosting the entirety of a data set. You're not de-identifying or disaggregating or doing any of these transformations that could potentially create a more secure system. Yeah, and it can be more expensive. So, and the last thing I want to mention on this is there is also a new theory of not just ELTL. So ETL was really the initial data science and data engineering move to create data warehouses. The newer trend is ELT, which allows you to do that transformation within the data warehouse. This has especially come into vogue because cloud hosting means that hosting costs are much less expensive. You don't have to worry as much about storing all of your data and processing all of your data because we can do it in the cloud. A new trend that has come up in the last couple of years is ELTL. So extract, load, transform, and then load again. And what that does is it allows you to extract data from a host application, load it into what we call a data lake. So this is no longer a data warehouse. This is a raw lake of data that is just every single piece of data that you can possibly get into a storage system. Then you do transformations on that data and then load it into a more refined data warehouse. And what this does is it decreases the security concerns that we talked about, because you're only allowing users access to that data warehouse, but the raw data is still living in that data lake for your more experienced users and data engineers to have access to. Another aspect of integration management is a data factory. So a data factory is often proprietary. AWS has one, Azure has one, so Microsoft. I think Snowflake has one, Informatica has one, and it is often a plug and play, point and click system. So what I mean by that is it's out of the box. You can sign up for the service and use it that day. You're not customizing it. It is there for you to use. And point and click means that it's a low to no code. So you don't need to have experienced coders on your data engineering team. You can have individuals with low to no code experience still creating integration data pipelines for you between applications, because there's point and click and drag and drop options. These are really helpful in organizations where it's difficult to find resources. We know that data engineers and data scientists are a rarity. We are a rare breed. And so organizations don't always have the benefit of having someone with true data experience, especially with data and coding experience, on their staff. And so having these point and click systems available allows them to do integration while also having resources in-house. APIs, I'm sure all of us have heard of APIs, application programming interfaces. These are connections between applications and connections that allow us to bring data into a data warehouse through a specific endpoint. And so by creating this, by having this API, we can do API calls. So like get, push, send, a couple of other different ones. It's very basic. It's very driven by often JSON, so solely the data that is available in its very raw form. And what that allows us to do is to create these really lightweight applications online and have those websites hosting data that can easily be called down. If anyone is interested, I know someone mentioned they're with public health. A lot of open data portals have APIs where you can just call data down, and it's very lightweight and easy to use. Okay, finally, with integration management, I want to mention environments and environment management. So when we talk about data warehouses, we want to talk about them as if we are software engineers. So we want to talk about data warehouses and other data infrastructure with test, development, and production environments. We want to have this distinction between where we're doing data work to ensure that we can have these security requirements and we can have a truly refined production environment while also having, you know, a test environment that our engineers and our analysts can play around in and not have to worry about it being client ready and giving them that sandbox to play in. So as I mentioned here, often, or the way that this process should work is development, you know, the really R&D aspect is done in the test environment, then true development is done in the development environment, and then finally code gets pushed to production. Any questions on integration management? So.
I have a question.
Go ahead.
So when you mean to say production, are we going to show the like the visual statistics of the data, or are we going to project the whole data? Like, how are we going to project them?
Yeah, so that's a really good question, actually. When I'm talking about test development and production environments, I more mean the overall theory of what those environments mean. And that can be applied to any type of, or really any step in the process of pushing data out. So you can have a production data warehouse that is meant to be for or consumption by data analysts within an organization. So very data literate individuals are going in and they might be running SQL code, or they might be running Python or R against that production data warehouse. You can also have production visualization centers. So like a production Tableau environment or a production Power BI environment. And so that's your production visualization to tell a story to your end users or your clients on that is truly refined and ready to be consumed.
I got you. Thank you.
Of course. Any other questions on integration management?
Hi, Amanda. I actually do have a question now that I think about it. So you mentioned that there are some low to no code solutions for data, which is blowing my mind a little bit because I think I just kind of assumed you had to be a web developer in order to work with data. Could you give an example of like a service that would be low or no code that you could use? Like
yeah, absolutely. There are a ton of them. One that immediately comes to mind is Excel. So people don't think of Excel as truly an analytics platform. It is, you know, spreadsheets are some of the first data analytics platforms that we have. And while there are possibilities to code really extensively in Excel, you know, it's not necessary. Other ones that I can think of, you know, Tableau is another good one where you can get really intense on the back end and create, you know, a really beautiful star schema and then visualize out from there. But you can also just drop a data set in there and then kind of drag around all your metrics. One that I use in my work is Azure, and it's actually called Azure Data Factory and Azure Synapse Analytics. And so what that is they create these pipelines where Microsoft has truly coded what I have in the past coded in Python. Which just makes me feel like I've wasted a lot of time in my life. But they have these widgets that you can drag onto what is essentially you know, a workspace and create integration by identifying what your source is and where you want the data to go, and you know, it allows you to connect those pretty easily.
Thanks for answering my question. That's wild.
Of course. Okay. So next I want to talk a little bit about data quality. This is really important. I don't know how to stress just how important your data quality is. There's a saying in data science, bad in, bad out. So junk in, junk out. If you have bad data going into your system, you will get bad analytics. You will make bad decisions and your data will be junk. Also, 90% of a data analyst's job is cleaning data. Like we all aspire to be able to grab that really beautiful clean data set, you know, that's squeaky clean right out of the laundry, but it never happens. There's always a lot of data cleaning that has to be done. So ensuring that your data is quality and that you have some sort of cleaning process is really key. So like I say here, yeah, insights from dirty or inconsistent data can be more dangerous than no data support at all, because it will be steering you in the wrong direction, whether it's biased or whether it's incomplete. You can be making these drastic decisions based on bad data and steer, you know, billion-dollar companies make decisions on data. If those billion-dollar companies are making bad decisions because they have bad data, it could ruin an economy. So data quality is extremely important. So there's some significant processes for data cleaning. Some ways to go about it is proprietary scripting. So this is not low code. This is truly for the developers of the world. You can build your own scripts with Python, with R, with Java, with really any language you'd like. My preference is always Python or R. But you can build scripts that do basic data cleaning. So you can write scripts that will check your data types and make sure that every single row for a column that's supposed to be an integer is actually an integer. You can also do things like making sure that if it's not an integer, it can remove any characters. Or if there's a space and there's not supposed to be a space, like a leading space, then you can get rid of it. And so you can code these really basic data cleaning aspects and create proprietary scripts that are your own, that clean your data sets in a pretty quick manner, that do the basic things for you. There are some out-of-the-box extensions, so you can buy some data cleaning solutions. One really interesting one that I'm liking lately is the ability to get address cleaning. So that allows you to take an address data set that might have been typed in manually or just really inconsistently, and you can compare it against this data set, and using the scripting that this out-of-the-box extension has, it will clean your addresses for you. So for example, if an address says str period, and then the next row in the data set says street, but it's the same address, it will be recognized as two different addresses. This application would go through and clean that up to make sure that they all say street. There's basic manual cleaning. So what this is to go back to our Excel example. Basic cleaning is just going through and making sure that you know, your dates are dates, and excuse me, and that you have no nulls in columns that are supposed to have no nulls, and you have other basic data cleaning like that. Usually this is on smaller data sets. I don't like to do this on data sets that are longer than 100,000 rows because then it gets really complicated, especially in Excel. And then I just go into coding, but basic manual cleaning is always a valid option. And then finally, there's machine learning, especially around consistent data. You can do machine learning to actually clean your data and identify data quality. So any questions on data cleaning? Because we're gonna jump to quality after this, and it's very different.
Not necessarily a question, maybe a comment or whatever. When you were talking about address cleaning, it just popped into my mind, like when you order something online and like as the end user placing an order through a company, it'll often pop up after you put your address in, it pops up with like a suggested address, which is basically the same, but it's like whatever format they want it in or whatever. So I guess it just made me think like a lot of places are kind of pre-cleaning things by doing that maybe, and that's a similar process to what you were talking about.
Yes, absolutely. So organizations, I think that is a public data set available from the USPS actually. And what they do is they provide that because it makes things easier for them. And it is, to a certain extent, machine learning at work. It is recognizing that you typed in a specific thing that is similar to another thing in a data set and saying, well, this is close enough. I think this is also your address.
Yeah, that happens to me also. Like, I think Apple is one of the best example for that when you check out. Yeah.
Yeah,
The
definitely.
the recommended address and your address which you entered, it shows the difference between both.
Yes. Yeah, so that is a machine learning example of data cleaning that is done in real time as you enter data. Any other questions on that? So next we're going to talk about data quality as opposed to data cleaning. So data quality is the idea that the information that you're consuming is of a quality nature, which I know it's terrible to use the word in its own definition, but because organizations can define quality in their own way, it kind of is a variable within that sentence. So there are just a few things that you really want to keep in mind around data quality, no matter what you identify quality as. And that's automated data collection versus manual data collection. So automated data collection is clean. It is clean quality. You can count on it to be correct, as long as you told it to do the right thing. So it's that catch-22 of a computer is always right because it always does exactly the right thing that you told it to do. So if you told it to do the wrong thing, you will collect non-quality data because you, the human, screwed up in giving it instructions. So this comes from sensors and software systems. You know, every time you run your credit card, data is collected. Every time you, you go to the doctor and they scan your insurance card, they collect that data and it's automatically collected. It is going straight from your card to the machine and the system that is collecting the data. There is no human intervention at all, which is great. It's really clean, it's high quality, it's consistent. The data types always line up. You know, you can't fat thumb a number if you're a machine. But one of the things that you run in with automated data collection is it's very limited in the types of data that can be collected. So for example, with sensors, We are starting to get a lot more types of data, but we're still limited. You know, it's still, is this happening or is it not happening? So we, within Syracuse University, I believe, implemented a lot of people counting sensors around campus to make sure that people are, you know, are not overusing rooms, especially during COVID. And so, you know, as someone walks under a doorway, it says, you are a person, I count you. So it's like person or not person. For those of you that get this reference, it is hot dog or not hot dog. And that is a Silicon Valley reference, I apologize. So it's very limited in what you can do with it. The opposite end of the spectrum is manual data collection. You can do so much with manual data collection. You can do qualitative data collection where you actually sit and interview people, or you can do survey data collection. You can do a ton of stuff with human intervention. However, your quality is going to decrease drastically. You have inherent bias, you have people getting in the way. We are such unreliable counters. And that's a lot of what data is counting. And so unfortunately, where you lose the data quality is where you do often get those details of the story that you want to tell. So it's really walking a line between wanting that more detailed data versus ensuring that your quality is high. Questions on that? Yeah.
So you were mentioning about automated data collection, right? So sometimes it should not happen, but sometimes if there is inconsistent data, how can we overcome that? Like,
yeah, so automated sensors can collect bad data every once in a while. One thing that is often done to combat this is, and that I don't believe we have scheduled for this training arc, but maybe next, is implementing machine learning algorithms, especially random forest algorithms that will, or best fit algorithms that will identify what the norm of a data set is and continue to re-identify what that norm is as the data set grows, and then create trigger points and notification points if data seems a little wonky. You know, if a sensor is collecting integers between 1 and 10 for 3 months, and then all of a sudden it collects the number 55, that would create a trigger. So often in these automated systems, you can have even, because the collection itself is being automated, we humans don't have to do it anymore. It gives us the opportunity to go and do cool things like design machine learning algorithms that can then monitor that data collection.
got you. Thanks for answering the question.
Of course. Anything else on this? Okay. So the last piece of the data governance or I guess the data fabric that I want to talk about is references and metadata. And this is actually getting kind of it's kind of having a renaissance right now, which is I love to see because I love documentation. And references and metadata are a lot of documentation. It's a very specific type of documentation. So metadata is data about data. And what this means is it gives all of the context and the back-end understanding of what a data set or a database is. So a piece of metadata might be the definition of what a metric is. on a given column. It might be a qualitative paragraph about how the data was collected. It might be, oh, I have some of them listed here. Descriptive statistical system data. So system data is where the data was collected. Was it collected through mobile? Was it collected through Windows, Apple? So it gives that type of system data. Operational data, that gives, you know, the like what part of the process does this piece of data support? Often we're collecting data to support processes or to refine processes. And so operational data will tell you which piece of the process map this data supports. Administrative is things like timestamps or collection chunks, which is not a technical term, but what I like to call the pieces of data that are collected together. So I often in the past, this has been referred to as batch, because batch processing would happen on a regular basis. We do still use batch processing a lot. I use it very often, but we also have streaming analytics that still do batch, what is effectively batch processing at a micro level. And so I call it chunks because they're both chunks. And so some administrative data might be like, what chunk of data was this delivered with? And then structural data, this is kind of like the mapping of a database itself. How does one table connect to another? What is it built on? How does that ETL process work for this specific piece of data? What is the lineage? And so lineage traces this single metric over here that you're seeing in a visual back through all the transformations it's gone through, all the way to its collection point. So you can see completely transparently how that piece of data was collected. So references and metadata can be really, really not just important, but I don't even know the word. They can be so integral in the data that you're using and in the analysis that you're going to put out. Any questions about references and metadata? So I want to do a quick discussion. We went through a lot of stuff today. We went through a lot of stuff last week. What do people think about the different areas of data science? Is there one that really draws you in? What do people think?
I can go first. So for me, just over the last couple of series and just in the books that I read and the conversations that I had, the most interesting part about it for me is just trying to figure out where all the pieces fit. So trying to see the big picture, right? I talked a little bit earlier about integration from source to target, and I'm just trying to understand like the big picture of like, how do you get from the source, collecting all the metadata, making sure your governance is in place, to somewhere where you're in the cloud or on-prem and your users are able to access it via Tableau or a MicroStrategy.
Awesome. You are a woman after my own heart. I am a data engineer first and foremost, and that is what data engineers do. So that's really exciting. And really wraps together all of these aspects, because to go from the source to the sink, which is what we call like the end user consumption model really requires you to touch on all of these aspects of data.
Yes. And I guess my question for you now, the follow-up is, you said you're data engineers. How do you learn all of the, or what would you suggest for people who are trying to learn about how to do that in different areas, right? There's so many tools out there and so many different options that a client or a company or organization could take. So what would you suggest?
I would suggest trying to stay as organization agnostic as possible. And by that, I mean, like, there are a lot of proprietary tools. Microsoft has a proprietary tool. Amazon has a proprietary tool. There are all of these things that that can draw companies into using a monolith and then getting stuck in using a monolith. Also, learning that monolith's tools has the potential to kind of back you into a corner of being required to use those tools because that's what you learned. So I would say try to do the same thing. So come up with a thing you want to be able to do, like a process you want to be able to functionally build, and do it in 3 or 4 or 5 different tools. Do it with Python, do it in Azure, do it in AWS, build it in R, build it in Snowflake, and make it simple. You know, you don't have to do these crazy machine learning things first off. You just need to know the basics. You just need to be able to get into a tool and start playing around and set a goal for yourself and say, I want to get there. How do I get there?
Okay. That sounds like a fun project to start, or a reasonable project also to start.
Oh, and I completely forgot to mention at the top of this call, but I mentioned this last week. We will be introducing a project series sometime in the next couple of months. So as we go through these discussions and training sessions, keep that in mind. You will be able to team up or do something on your own, and we'll have some sort of project series where if you are interested in something like that, there will be working time and space for you to ask questions and have resources and everything.
That would be really great, the project series. Yeah, I look forward to work with everyone.
Awesome. So anyone else kind of thoughts on the areas of data science that we've covered?
Based on what you covered tonight, something I guess I hadn't thought too much about that's appealing to me is the data cleaning. And also the fact that you could even apply machine learning to that. That's really interesting to me. So, and I could think of a project idea based on that. So
good. Yeah, that's what this is for, is to kind of get those wheels turning and think about ways that you can implement this in real life. So I do have a couple more slides I want to go through. I do know that we only have a little bit of time left. Keep in mind, if you do have to drop, this is being recorded. So, you know, within the next X number of days, we will hopefully have this up online, and I'll be sharing the slides again. So if you do have to drop, we will have those available to you. So next, I just want to go over quickly some different data types. So this is very basic data theory, but stuff we have to get out of the way. So Boolean, binary variables, yes, no, true, false, this is very, it's the most basic bit of data. So it's a single bit, and it's used a lot to produce, especially with Internet of Things becoming so prominent, and sensors, the Boolean bit has kind of made a comeback. So that's very important. Numeric is a variable expressed explicitly as a number, negative infinity through infinity. So, so numerics are different than integers. Integers are whole numbers, whereas numerics are can also be decimals, so a float. A categorical data type is a qualitative variable represented through a number. So for example, we've all seen those questions on a scale of 1 to 5. And so what you're really saying is, I am very pleased with my service, but what they're seeing is a 5. And so that's a categorical. And a string is qualitative data, it's text. So narrative variables, or the variables of those categoricals. So if the number is 5, then the string attached to that 5 is very pleased with my service. Finally, I want to touch on primary keys. So primary keys are a column within a data source that can never be null, and is required for any row within that data source. Often what a primary key does, it's unique within a table, but not necessarily unique within a data set. And this will connect different tables to one another across a data set for that variable. So say we have a list of addresses. Every address has a primary unique identifier. That's a primary key. That key can then be used to a table of home sales. So that home sales table has addresses listed more than once on it. So that unique identifier is no longer a primary key on the sales table, but because you have that primary key on the addresses table, you can connect those two tables together. Questions?
This is something which runs in a programmer's blood since childhood.
Yes.
Yeah.
Yes, this is big in software and programming, and I am realizing as I dig deeper into both of those communities that there should be more overlap between the two than there is. So I am hoping to bring more programming into the data world. So finally, I want to touch on data literacy and communication. So I skipped a discussion slide. We'll go back to that discussion slide next week when we go to actually have the full discussion. But I really want to talk about data literacy and communication because it's key. What we do is attempt to, I like to think of data as a language. Data is representative of of itself in a language that most people don't understand. But because we are data experts, because this is our job, we understand data as a language, and our job is to communicate that language to others who are maybe less data literate than we are. So this really gets to, I believe Kelly brought it up at the beginning, the storytelling through data. And so you want to have the ability to communicate the analysis and the conclusions that you're creating with your data. You can't just You can't just do an analysis and hand a spreadsheet to a business, a line of business employee and expect them to understand it. You have to tell that story of the data. And data literacy comes with that. Today is an exercise in spreading data literacy. And so so really key in not only key is communication, but also spreading data literacy as you communicate it to others. And finally, you want to start with the goal, not the data. We want to remember that data is always a tool by which we get to another location. So we're always attempting to solve a problem with data. We are not, it's really fun to play with data for data's sake, but ultimately, the point of the data itself is to solve a problem. Okay, so any questions? I'll stop sharing and we can all chat.
So not a question, but a comment. Data literacy and communication was my answer to the discussion question. I just couldn't come up with how to phrase that. And I sat here oh, how should I say this? And that's it. That's the thing I'm most interested in currently.
Awesome.
So thanks for putting that out there.
Of course, I am, obviously, because I am doing this here today, I am a huge proponent for data literacy and communication. So go data literacy.
I have a question.
Right.
Yeah. So once you have the data that you want, let's say you start with a silo, and then you did your programming and everything, and you get the data that you really wanted, the quality, with the quality that you want. Then when do you decide to delete the original data?
So that's a really good point. And that comes around with, we spoke about it last week a bit, data governance policies. And so data governance policies are the way that an organization handles its data. So security, collection technologies, different stuff like that. But also, how do you delete your data? And so really that's up to an organization to determine. In some cases, it's law, though. So for example, within the healthcare space, you're required to keep healthcare records for a patient. I believe it's up to 7 years on record. So you can't delete records for healthcare patients until those 7 years are up. There are pretty aggressive expunging technologies that will fully erase data. Obviously, it can't trail data, it can't track data through the internet, but if you know that your data is all local on a single cloud, or you know all the instances in which your data exists, there are technologies that that will fully wipe data once you know that it's available to be deleted.
Okay, thank you.
Any other
I have something to say. I mean, it's just like a comment. So I think data should be given to user specific roles, right?
What do you mean by that?
So like for example, if you're working in a team or a department, you need to be given access to the specific data that you need, not the whole data, right?
Right.
Because
Yeah. So there's two theories behind this. There is access first, and there is access only, I think it's called. It may be named something different, but the idea is from two different theories on this. Do you provide access always to people and then take it away as needed? Or do you say you only have access to the data that you need and we'll give you access if you prove that you need to use that data?
Yeah, that is what I mean to say. Yeah.
So that's a really interesting theory of security upon data, and
Yeah, and the second thing is again, I'm touching this point. So I think even when we collect automated data, we need to make sure that we gather consistent data more than inconsistent data. I think there should be a way.
Yeah, for sure. If none of you have listened to it, you should absolutely go listen to the Banana Data podcast. It's fantastic and I love it. But one of the things that they talk about a lot is ethics in AI. And so one of the things that they are proponents of is consistent human intervention in AI. So even though we have these AI systems, automated data collection, there should still be a point of human intervention to ensure that we're creating that consistency, that the machine is not going off the rails and no one's monitoring it.
Yeah, got you.
Other questions?
Going back to last week or a week and a half ago, the last class, I also actually posted this in the Slack channel, I think yesterday, but I'm still a little confused on the difference between data infrastructure mapping and schema development. They both kind of reminded me of entity relationship diagrams, which we worked with in Careers in Code, but I wasn't quite sure which that would fall under. And I was trying to get an idea of like, the difference between them with actual examples of things I might have seen or,
Yeah, here, let me pull. Oh, I completely missed your post. It's
okay.
I apologize.
Or anything, but
yeah, so actually both of these, let me just make sure. Okay, so data infrastructure mapping is a more specific type of object relational mapper. So, a data infrastructure mapping is just these reference points all around, and how do we map them together? Schema development is the actual, not physical, but without a better way of saying it, the physical development of a database's structure. So it's not the mapping of it afterwards. It's the design and coding development of the schema ahead of time. And then the functional laying out of that in code.
okay.
I think the best example of data mapping should be Google Maps.
Apologies, it is not like physical mapping. It is understanding the relationships between tables within a database. So mapping those relationships.
Oh, okay. Okay, I got you.
So if there aren't any other questions, next week we will be doing, I believe it's on Thursday next week, a discussion session. So we will be going in deep, and I want to hear from all of you about data theory and what we've done over the last couple of weeks. So yeah, that's next week. I don't have any other announcements. Ashley?
Not that I can think of.
Okay, well, thank you everyone. Thank you as always for joining, and I hope to see you next week.
Thank you.
Okay.
It was a good
Bye.
session. Yeah. Have a good night, everyone.
You too.
Thank you. Have a good
Thank
evening.
Bye-bye.
you.
Bye.
Thank you.